Area models and multiplication. I was going through my social media today and I saw a post from a parent who had an opinion about the way this multiplication problem was done. So just imagine if you had a student in the fourth or fifth grade that came home with a multiplication problem like this, the way you and I were taught, we'll probably look at this and be confused as to why are there so many boxes and where did these numbers come from. 9 times out of 10, you will go right back to showing your student or your child how to do this method. Let's take a closer look as to why multiplication is being taught this way. So let's look at this from an agricultural point of view. So let's say you have a farm. Let's pretend this is a farm and you have to plant some crops. So you have some space over here, you have some space over there, and you have a little space over there, and you kind of want to divide it out into different sections. How much would you be able to plant in this area versus that area, so on and so forth? And just think, this is a small yard, but just think of this over thousands of acres or land that's so far back you can rarely even see it all the way to the end. All right, so let's look at this on a graph. There's my x-axis in red. And let's pretend this is in yards. So there's 100 yards, 200 yards, 300 yards, 400 yards. Green is my y-axis. 100 yards, 200 yards, 300 yards, 400 yards. And so let's carve out a plot of land. So I'm going to have 100 yards width by 400 yards in length. So what would the area of this green plot of land be? So this is 100 yards wide, 400 yards long, multiply, and your final area is 40,000 square yards. So multiplication done like this in this manner, that's what we call an area model. And if you notice, when I calculated, I said 40,000 square yards. Look how this grid creates squares. Area measures how many of those squares it would take to fill up a space. That's what we mean by square units. Let's use the area model to simplify this multiplication example. From someone who teaches upper-level high school math courses, this method really is about strengthening number sense through the use of place value. So let's use the area model to multiply 312 times 23. So first we will use place value. So we are going to organize everything into our table. So across the top, I'm going to use place value for 312, which is 300, 10, and 2. And across the side, 20 plus 3. So if we multiply 300 times 20, you'll get 6,000. 10 times 20 is 200. 2 times 20 is 40. Now we're going to do it again. Now we're going to go to the bottom row. 300 times 3 is 900. 10 times 3 is 30. And 2 times 3 is 6. At this point, you can add all 6 numbers up and you'll get your total. As you get more comfortable with this process, you will naturally begin to gather numbers together so that you can add much quicker. So I do agree this process is longer than the traditional method, but why is this necessary? Algebra 1 will rely on this skill more than most will give elementary school teachers credit for. For example, 4x to the second power plus 5x minus 6. This is a trinomial because this has 1, 2, 3 terms. This is a binomial because it has 1, 2 terms. And we can multiply these also. Notice how I placed the trinomial across the top and I separated them by each term. And notice how I placed the binomial across the side and I separated it by its terms also. Now we will begin to multiply. Three x times 4x squared is 12x to the third power. 3x times positive 5x is positive 15x to the second power. 3x times negative 6 is negative 18x. Negative 2 times 4x to the second power is negative 8x to the second power. Negative 2 times positive 5x is negative 10x. Negative 2 times negative 6 is positive 12. And just as you have to do at the elementary levels, you have to take everything that you have in these boxes and add them up also. So the final product is 12x cubed plus 7x squared minus 28x plus 12.